right, ladies and gentlemen, let's take a look at lesson 5.4C. What we're going to do now are solve quadratics. But we're going to solve quadratics that would originally be no solution because we would end up taking the square root of a negative. Now we're going to show you what to do that we can take the square root of a negative number and have our imaginary solutions. So this is going to look very familiar to 5.3D. So we're going to get the variable or parentheses with the exponent by itself. We're going to do exponents by taking the square roots. We have to remember that we're going to have two solutions, the positive and the negative, so that's where we write that plus or minus. So there's going to be a lot of things here that I kind of go quickly through. What we're going to keep in mind, though, is that we've added in this idea of being able to take the square root of a negative. So let's take a look at these 4 examples. So just like before, we undo adding 3 by subtracting 3. So we have 2x squared left over there is equal to negative 18. We're going to divide by 2. And we get x squared is equal to negative 9. I'm going to take the square root now. So we get x is equal to, let's put in our plus or minus, and now we need to break this down. The difference here is our first step is going to have to be this negative 1, which is going to come out as an I. And then 9 comes out as a 3 because it's a pair of 3s. So our answer is plus or minus 3i. If we take a look at number 3, it's the same thing. We're going to undo adding by subtracting, and that's just a coincidence. We can have subtraction that we undo with addition. We have 3x squared is equal to negative 60, and then we divide by 3. We've got the x squared again. We have a negative, and now this is 20. What we're going to notice here now is when we take the square root, it's not a perfect square, but we're going to do the same steps. X equals plus or minus, because we've just taken the square root of both sides. We're going to call this negative 1 times 20, and that negative 1 is going to come out as an I. 20 is 4 times 5. The 5 is prime, so I underlined it. 4 is 2 times 2. And so everything that we circle comes out. The pair of 2's comes out as a 2, and the negative 1 comes out as an I. The only thing that's left here is the 5. So we have plus or minus 2i, square roots of 5. Now we have our parentheses. We take care of the operations outside of the parentheses first. So I have multiplication and exponents, so I need to divide by 2. So we have x minus 3 squared is equal to negative 25. I'm going to take the square root of both sides because I can't get inside there without getting rid of their radical. So we have x minus 3 is equal to plus or minus. We're now going to simplify that. And as hopefully most of you are noticing, 25 is a perfect square, so we have that pair of 5s. But the negative 1 is coming out as an I, and the pair of 5s is coming out. Now the difference here is I have to add 3 to each side. But even though 25 is a perfect square, because it was negative 25 to start with, we have this imaginary number. So we added 3 to each side, which makes it a positive 3. We have our plus or minus, and then 5i. We're not going to be able to add those together like we did last week. It's going to have to stay as a complex number because one of them is imaginary, one of them is real. All right, so let's take a look at our last example. And as you can expect, it kind of combines everything. So we've got some addition outside of the parentheses we have to take care of. So we have 4 times x plus 2 squared. Remember, we're not going to do any arithmetic on the left-hand side here. We're just going to undo our operations. So that's going to give me negative 192. I'm going to divide by 4. We have x plus 2 squared is equal to negative. We should have 48 here. I now have to take the square root of both sides. So I have x plus 2 equals, we took the square root, so we're going to put plus or minus. And then we have negative 1 times 48. Negative 1 is going to be circled, and then we keep breaking this down. This is 3 times 16, and then 4 times 4. 4 pair of 4s, so we're going to have 4i square roots of 3. We have an imaginary number. We have to undo the adding by subtracting. So we're going to subtract 2 from each side. So we have x is equal to, because we're subtracting 2 this time, it's a negative 2. And then we have our imaginary number of plus or minus 4i square roots of 3. So as you can see, these examples fit quite nicely with what we did last week. We just have to pay attention to our imaginary numbers. Have a good evening.